Hello, my name is Darren Sakala, and I'm going to present today a paper by Major Daniel E. Schoeni called Agile Methods in Cyber Acquisitions in the Department of Defense. So for a brief overview of the paper, the Department of Defense is the leading combatant of cyber attacks in the United States. It often acquires cyber defense tools that are out of date and uses these tools for long periods of time. I'll go into further detail as to why they do this in the paper. It's really no longer feasible to do this because software is constantly evolving, and so we need to address this constant evolution in software in order for the Department of Defense to stay up to date. As a solution to this problem, agile methods have been proposed with the sole purpose of trying to keep the Department of Defense up to date with the latest paradigms in cybersecurity. So for some background on the task at hand and the issues that are faced with the Department of Defense, obviously the nature of cyber attacks vary, and usually the nature of the attack can be deduced from the attacker and the victim. So if the victim is an entity like, say, Target, more than likely the attacker was after financial information. Or if the Department of Defense was the target in this case, often the attacker is after some sort of state secret or secret blueprints or any sort of classified government information. And so as a result, the main cyber threats come from hostile states or cyber terrorists, organized crime, or loosely organized anarchists or lone wolves. And really, the Department of Defense is a common target because of perceived vulnerabilities and the value of its data. So the author also gives an analysis of what can be called cyber acquisitions, which is effectively software development, software requests, or any sort of software acquisition. So the Department of Defense is obviously not alone in the cyber revolution. So 90% of their new weapon systems are reliant on software. And where you have more software, you're going to have more vulnerabilities. The military often finds itself unprepared for cyber attacks because it uses out-of-date prevention devices. The full gestation time from initial conceptualization all the way to final rollout can take between 7 to 10 years, just based on the slow-moving methods that the Department of Defense uses. And so even though it has the largest budget in the world, it really is hampered by these slow gestation times, and it can't keep pace with new technology as a result. Luckily, leaders realize that this is a vital issue, and they're working to adapt and come up with new solutions to this problem. So the author also presents three assertions. The first is that given that all others are equal and that both parties are playing on an equal battleground, superior technology will usually prevail. This is a concept that dates all the way back through military history. If two armies are fighting on the same battlefield with an even playing field and the same number of soldiers, usually the army that has superior technology is the one that's going to prevail. Also, not all software used by the Department of Defense is mission critical or specifically tailored for military purposes. In instances where you may have something like human resources software or payroll software, this doesn't need to be tailored specifically for the military. And then also, software is written for the military by uniformed members or civilian employees or independent contractors. So this idea of using Agile really applies to all of these, not just uniformed members and not just civilian employees of, say, Lockheed Martin, but it needs to apply to everyone that's affiliated with the Department of Defense. So before Agile, there was the code and fix method. And so essentially what this is you have a lack of a formal structure, and you essentially write code, test it, and then fix it. This is actually really suitable for small projects, but not suitable for large, complex solutions when you have a high cost of failure. And this really developed in the early stages of programming and software design, when your solutions weren't necessarily as complex and didn't use as much memory, for example. This was really popular in the 1950s and 60s, again, when problems weren't complex that required a lot of processing time or processing power. These issues that were found in the code and fix model were satisfied by the waterfall method, or the waterfall method was created in order to address some of these issues. So the waterfall method is a structured method where you have well-defined stages capped off by a milestone or a deliverable. Usually these stages can be summarized into a requirements or concept phase, a design phase, an implementation phase, a testing phase, and a deployment or a release phase. An issue with the waterfall is that it's often slow moving, and so you have to, with a high emphasis on documentation and traceability. And so part of the issue is that you at the end of each milestone you have another deliverable to implement, and each of these deliverables doesn't necessarily always pertain to the solution at hand. Your deliverable in the design phase, for example, may be a high-level design or a low-level design, and your deliverable at the end of implementation may be a 85% completed solution. This really isn't suited for projects where you have ambiguous or evolving requirements. The author goes on to state that poorly defined requirements are responsible for 85% of all failed projects. In the waterfall method as well, it's really hard to address changing requirements or changes in your design, because when you change something in your design, say during the testing phase, you have to go all the way back to requirements, readjust your requirements, then design it, and then implement it, test it, and then you can then deploy it. So you have to essentially start a whole new waterfall with each design change that occurs. The author also presents an overview of Agile. And so essentially, Agile assumes it's impossible to know all your requirements. It assumes a constant change in that sense. So when you're going into a project, it's almost impossible to pin down all of your requirements. Some of them may even be ambiguous of the ones that you have pinned down. Agile also uses iterations, where you release a working version of the software at the end of each iteration. And so, for example, this could be in the form of a sprint. But essentially what each iteration is a mini waterfall. So at the start of a sprint or at the start of an iteration, you come up with a list of requirements or a list of goals. You design to those goals, then you implement those goals and test them, and then you release them. And effectively your release is where your working version is released at the end of each sprint. The emphasis of Agile is really placed on working software as opposed to extensive documentation. And the author goes on to quote Barry Bain by saying, "A prototype is worth 100,000 words." And so obviously what he means by this is when you have a working prototype, that's something you can present to the customer. And it's very easy to show a customer how your prototype works if it already exists, as opposed to having your customer read through hundreds of pages of technical info on how it's going to work when you eventually create it. And so in the same vein, when you're working with Agile, you want to listen to customer input, adapt the current prototype, and then demonstrate the new prototype to the customer again. And then you want to keep doing this over and over and over again until you eventually reach your end goal or the project is no longer required. So in order to understand why the government does things today the way they are and why there's such a big issue with it, it's important to understand how they've acted in the past, or what policies, what software and methodologies they've used in the past. So the government actually has used Agile processes in the past to rapidly develop new technology. This was the main software development methodology, not just for software, but for product development all throughout World War II and through the space race, through those rapid advances in technology that really started in about 1939 and went all the way up to the late 80s. The government really was a pioneer of some of these new methods. They were the ones doing most of the development and most of the innovation at the time, and so they were the ones that decided, hey, this is something that would work really well for us. One shining example of this is actually the U-2 experimental aircraft, and so this was essentially a spy plane that was designed by Lockheed Skunk Works, and it was tested extensively at Area 51. But essentially what the Skunk Works team did was they built a prototype, they tested their prototype, they adjusted based on the new requirements and the test results, and then they kept testing again until it was satisfactory. And this plane actually ran several spy missions over the Soviet Union in the 60s and 70s. So one important event that happened in the early 1980s was that the government required all of its entities to use waterfall. The DoD really felt that the key to having a quality weapon system was to use an extremely rigid structure, and waterfall fit this bill. Essentially, when you're using the waterfall with something like this, you can see transparency all the way from your requirements phase down to the actual release. And most military senior leaders like that because it allowed you to have a close eye on everything that was going on within a project. For other reasons, this may have been caused by the desire to cut out poor spending or misuse of funds as well. Where you have that transparency, you can really see how everything's going along and down the line. But as a result, software development was really stifled, and efficiency sharply declined by most government employees. The author goes on to state that 75% of projects undertaken during this time period of the early 80s to the late 90s actually just straight up failed. And 2% of all those projects were actually used without any extensive modification to their original requirements and original goals. that's a really poor figure, just as an aside. And so the government also realized this. They have actually attempted to go back to these iterative or agile methods, and really they haven't had much success. They've had several different regulations or mandates with the hopes of trying to go back to the way things were. And they really haven't taken root, and especially with recent memory. The author also presents the current state of DoD processes, and really they still use waterfall even though it puts on the guise of using Agile. The core issue is that they still value rigid documentation and requirements over working prototypes. This leads to design inflexibility because you're still caught up in this massive web of documentation that you have to go back and modify should your design requirements change. Most programs can't even start really until the requirements are vigorously refined and approved. And this approval can take several months. And oftentimes, by the time you draft your set of requirements and you finally get them approved, they may have even changed from your target system that you wanted to design. So what are some of the problems with this model? Well, there are two questions you really have to ask yourself. The first one is, what happens if software requirements change? And the second is, what if the enemy's technology accelerates? It's better than ours. Those are two problems that you have to address when you're working with waterfall. And obviously, when you have a static list of requirements and your technology is rapidly evolving, that's an incompatible mix because your requirements are going to have to evolve to reflect new changes in technology. Another problem that's arisen is long product development times. And this can partially be driven by bureaucracy and the multiple entities that need to approve a project before it even starts, sometimes even including Congress itself. Part of the issue with this is that most congressmen or congresswomen don't have backgrounds in software development or very low-level electrical engineering, for example. Their backgrounds are often in politics or business. And so the level of oversight that a congressman would need over a project like this sometimes isn't as much as that would be necessary, just because they don't need to know the intricate details of requirements of such a software module. Also, current leaders of the Department of Defense, they really value the old processes, and unfamiliarity with the new process can often be scary. So what are some proposed solutions? Well, not everything in the Department of Defense is bad, and not everything that makes up waterfall is bad either. Really, you want to take the best from both worlds and come up with a common solution. So, with that sense, waterfall can be used for a static project where your requirements aren't necessarily changing, while Agile can be used for projects that have potentially volatile requirements. So an example of an Agile project could be something along the lines of cybersecurity, whereas a static project that could be used would be like a fighter jet or a ground vehicle. Those are two instances where you may want to use both realistically. You also want to deregulate software development, and so you want to remove any regulatory bias towards waterfall or any regulatory bias towards Agile for that matter. Let program managers and let teams decide what's best for them and what development model they should use. And also, try and clean up the bureaucracy. So remove congressional oversight to the minutiae where they're arguing about requirements or reviewing intricate technical details. Really, all Congress needs to do is say, what does it need to do, how does it do it, and how much does it cost? And lastly, the author presents the question of how Agile is going to help combat cyber attacks. Well, technology's rapid evolution means two things. Your enemy's technology is moving just as fast, if not faster, and your technology is quickly going to become obsolete if you don't update it. So Agile allows the target of a cyber attack to keep up to date with current technology or current software design techniques by constantly reevaluating the requirements and attempting to improve. So essentially, if you have a software module and you can use Agile on it, there is no true release phase. Your release phase occurs every 2 weeks, for example. So you're constantly going to be releasing new versions, and you can use those new versions as you see fit. Also, because minimal time is spent on project overhead, this allows developers to release your solutions more expediently. They can actually, without having to go through a 5-year process, for example, or a 5-year development time, they can actually develop a solution and then come up with new releases every few weeks. Without all that overhead, they're able to focus more on actually designing the system itself as opposed to documenting the system that they're going to design. Now, transparency that is lost in documentation is actually gained in having working prototypes and demonstrated solution. And I discussed this earlier where you have a well-defined solution that has already been implemented is worth 100,000 words on paper. And lastly, Agile can help you ensure that your technology is at least up to date, if not the state of the art. This is important to consider because when you have a state of the art technology, it allows you to be better than your enemies and to outsmart them. And so in conclusion, the Department of Defense continues to use methods that are stuck in the past. They are still mainly tied to waterfall and the rigid documentation that it provides. Part of the problem with the Department of Defense is just a cultural problem. They want to apply a one-size-fits-all process to all their projects, regardless of scope. The solution to this isn't really that clear, though. Agile procedures may help with the problem of timeliness, but it also holds a potential for a rollout of an unsafe system. And this falls on the role of program managers and project leads to ensure that the requirements are being met at the end of each sprint and to ensure that these design processes are following a proper validation cycle and that all releases are properly validated. But one thing is for sure, and that's that the Department of Defense needs to, at a minimum, keep pace with the current state of technology. And it should do this in order to protect itself and its constituents. And so my source is taken from the Mardigian library, and the title of the article is Long on Rhetoric, Short on Results, Agile Methods and Cyber Acquisitions in the Department of Defense, but written by Major Daniel E. Schoeni from the United States Air Force in the Santa Clara High Technology Law Journal in July of 2015. Thanks for watching.